Hello everyone. Hello everyone. Hello everybody. Am I audible to each and everyone? Good evening everybody. Am I audible to each and everyone? Is audibility absolutely fine? We are live now. This is Mohit here and welcome to the test book. सभी लोग मुझे देख पा रहे हैं, सुन पा रहे हैं, कंफर्मेशन देंगे. सभी लोग मुझे देख पा रहे हैं, सुन पा रहे हैं, कंफर्मेशन दो यार. Is audibility absolutely fine to each and everyone? जल्दी fast. Am I audible? Is it visible? सभी लोग मुझे देख पा रहे हैं, सुन पा रहे हैं, कंफर्मेशन देंगे. Am I audible? Am I visible? Good evening, the visualizer. Good evening, Swati. Fast, fast. Good evening, Nirmal. Hi, Shashidhar Angeri. All के हैं. Okay. Good evening, Dinesh. Good evening, Rajeshwari. Hi, Anigari. Good evening, Dinesh. Please join fast, guys. Good evening, Srinidhi Amai. Join fast, guys. Join fast. KPTCL means, okay, fine. I will tell you the meaning of the KPTCL. Don't issue at all. Pooja. Good evening, Srishti. Good evening, Monica. Good evening, Nitin. Good evening, Ragini. Good evening, Sayadri. Good evening, Nitin. Okay, fine, fine, fine. Join fast, guys. Good evening, Pratibha. Good evening, Dibyendu. Good evening, Mohammed Kaf. Good evening, Taj. Good evening, Sachin. Good evening, Suman. Good evening, Mahesh. Good evening, Shubham. Good evening, Pradeep. Good evening, Augie. Good evening, Nagra. Good evening, Rituraj. Ragini, this is the result of Detol. Good evening, Loknath. Good evening, Naveen. Good evening, Vishu. Okay, fine. So the thing is, guys, first sentence I will tell in English, then I will tell in Hindi. There is an exam of KPTCL, that is Karnataka Power Transmission Corporation Limited. It is the transmission company of Karnataka as an electricity board, and KPTCL have a JEE exam in this month. Fine. So there are so many students right now who are preparing for KPTCL JEE. So today I planned a one session for those students who are appearing for KPTCL JEE exam. But the thing is, this session is also helpful for all those students who are preparing for different JEE exams of this country, either from any of the state, that is UPPCL, UPRVNL, ONGC, MP Sub Engineer, and also guys, different that is Rajasthan JEE and different of electricity board exam. So this session is helpful for all JEE exams of this country. But the thing is, daily I will explain everything. Daily I will explain everything in English. Daily I was explaining everything should be in Hindi. But today, guys, we have some South Indian students, and some of them evenly don't know actually the Hindi, and they want to, sir, please explain and arrange one or two sessions for us, so that we can able to understand what you are actually saying. There are so many South Indian students, guys, we have, and they are continuously telling to me, sir, please arrange the sessions for KPTCL JEE and please taught in English. We want study from you in your 5 p.m. session. So guys, all of my North Indian students, today I can explain entire session should be in English. Are you able to comfortable in it? Are you able to comfortable in it? Just tell me fast. Just tell me fast. Are you able to comfortable? My English is very simple, no issue at all. My English is very simple, no issue at all. Yes, Preeti, yes. Okay, how many of South Indian students are there who are not able to understand in Hindi? Who are not able to understand in Hindi? प्लीज सर हिंदी में कीजिए. राज पटेल जी बोले प्लीज सर. बेटा 1 साल से हिंदी में पढ़ा रहा हूं, एक दिन अगर अंग्रेजी में बोल दूंगा तो कुछ दिक्कत हो जाएगी? एक दिन अंग्रेजी में पढ़ा दूंगा तो कुछ दिक्कत हो जाएगी राज? हाँ, एक दिन इंग्लिश में पढ़ा दूंगा तो कुछ दिक्कत हो जाएगी बेटा? इतनी भी अच्छी अंग्रेजी नहीं बोलता हूं मैं. how many of South Indian students are here who are appearing for KPTCL JEE and cannot able to understand Hindi, can't able to understand Hindi? Everybody, anybody else, I can entirely explain in English. If there are all of them students are able to understand Hindi, then I can explain in Hindi also. Fine. So today, guys, completely we can able to explain everything in English. Completely explain in English. If there is a problem with some of the students, they can just ask to me and hold on me, sir. Please one more time tell me in Hindi also. Fine. Okay. So please like the session first. We are right now 71 watching now, but there are only 27 likes. This is not a good deal. This is not a good deal. This is not a good deal. Please like each and everybody. Now the like was 36. Please increase till 65 fast. Good evening, Ritika. Okay. Now increase the like. Cross 47. Cross 50 fast. Cross 50 fast. Okay, fine. Okay, fine. So first of all, today is in our country. There is in our country, not in the world. There is a very biggest festival. So the first of all, Eid Mubarak to you all. Eid Mubarak to you and your family, your close ones from me. Fine. So enjoy Eid. Now, guys, today's first question is on your screen. A parallel plate capacitor is charged to 500 microcoulomb at 100 volt. It is then connected to another capacitor of capacitance 4 times the capacitance of the first capacitor. Find the loss of energy. How much energy will be lost? How much energy will be lost? A parallel plate capacitor is charged to 500 microcoulomb at 100 volt. It is then connected to another capacitor of capacitance 4 times the capacitance of the first capacitor. The capacitance of the first capacitor 4 times the first. Find the losses of energy fast. Okay, fast. Now, guys, the thing is, we have 500 microcoulomb capacitor, 100 volt voltage. Now, the energy stored by this capacitor should be C1 should be half CV square. Now, guys, this is half. This is 500 microcoulomb, that is 10 to the power minus 6. This is 500 coulomb, that is 10 to the power of minus 6, and this is your V square. What do you mean by V square? That is 100 square. Okay. Now, guys, the energy stored by the capacitor C1 is 500 divided by, that is 250 into 250. Yes. Okay, fine. 250 into 10 to the power 4, and again is 10 to the power of minus 6. That is, guys, 2.5 joule. 2.5 joule is the energy stored by the capacitor C1. Now this capacitor is connected to 4 times the capacitance of the first capacitor. Find the losses of energy fast. आज एकादशी भी है महाराष्ट्र में. एकादशी के पहले क्या लिखा है ये मेरे को नहीं पढ़ते बन रहा है. हिंदी में लिखा बहुत खतरनाक टाइप का, ये मेरे को पढ़ते नहीं बन रहा है. बट हाँ, एकादशी, हैप्पी एकादशी इन महाराष्ट्र. हैप्पी एकादशी. फास्ट गाइस, फास्ट. Too fast. I know there is a disturbance in noise. Guys, it should be clear within 5 to 10 minutes. Don't worry. It should be clear in 5 to 10 minutes. Don't worry. It should be clear in 5 to 10 minutes. Don't worry. Just listen. Yes, Vicky. Now, guys, there is another capacitance of 4 times the capacitance of the first capacitor. Find the losses of energy fast. Find the losses of energy. Now, guys, what is this value? That is 20 into 10 to the power minus 3, that is 20 milliweber. Fine. 20 milliweber means 0.02. This is 0.01. This is 0.15, and this is only 0.001. Now, how much energy will be lost? How much energy will be lost? The correct answer of this question is 15 millijoule. Today's your assignment, guys. Please just verify why 15 millijoule. Why 15 millijoule? Why 15 millijoule energy will be lost? The reason behind that 15 millijoule is that is the value of this capacitance. That is the value of this capacitance. Today you have to just analysis this question. Okay, fine. Okay, this is homework for today's class. I will discuss in next class also. Don't worry, because this is a good question, and I want everyone here should crack this question. Fine. Okay. Now next, find the RL to obtain maximum power from source to load. Find the RL to obtain maximum power from source to load. Find the value of RL from the source to load. Find the value of RL to obtain maximum power from source to load. Find the value of RL, guys. So the value of RL should be what? You have to calculate the Thevenin equivalent resistance, that is called RTH. Now guys, Thevenin equivalent resistance we have to calculate it, and here there is a voltage source which should be short circuited. So this point and this point, and this point. First, these both points are same. That is A and C, both are same. Now we have to calculate the equivalent resistance between B and D. First, calculate, guys. Fast, calculate. No, we need no notification regarding sub-engineer. Fast, guys. Calculate the Thevenin resistance between RTH. Find the Thevenin resistance between RTH. So, guys, the Thevenin resistance between RTH is, first you have to calculate, that is A and C. This is B and D. So this is your B. This is your D. Okay. Okay, sir. Now this A and C both should be the same point. Now the resistance between B and D is 6 ohm. That is 6 ohm. Sorry, B and A is 6 ohm. That is 6 ohm. Now the guys, the C, D and A. The D and A should be 3 ohm. D and A should be 3 ohm. And guys, you have to calculate it between B and D. B and D you have to calculate. Now, what is the resistance between C and D? That is 3 ohm. Fine. C and D, that is again 6 ohm also. That is called 6 ohms. Now this 6 ohm is like this. Now this 6 ohm like this. C and B. C and B should be also 6 ohm. Fine, 6 ohm. Now this 6 ohm parallel becomes 3 ohm. This 6 ohm 3 ohm parallel becomes 2 ohm, and the overall both resistors should become equals to 5 ohm. The correct answer of this question is 5 ohm. The current I in the network in the figure is, the value of current I in the network in the figure is, just calculate, guys, fast. Just calculate, guys, fast. Today I am completely explaining all the thing in English, so please cooperate, guys. Everything I can able to teach you should completely understandable, no issue at all at any stage of the time, at any stage of the solution of the question. The current I in the network in the figure is, and I also correct the jokes in English also, so don't worry. I can also correct jokes in English also, so don't worry. I can teach of same level in English and Hindi. I have an experience of United States and UK students for teaching English. They also know Chintu and Chinti, and our Hindi students also know Chintu and Chinti. Who are they? The current in the network in the figure. The current I in the network in the figure. So guys, this is a potential V1. This is a potential V2. Now you have to calculate the value of V1 and V2. What is the Kcl equation at V1? That is V1 minus 25 upon 1, V1 minus 0 upon 1, V1 minus V2 upon 1. That is V1 minus V2 upon 1. What is this, guys? 2V1 equals to V2 plus 25. Fine. Okay, sir. Fine. Now, what is the equation at V2? The value of V2 is V2 minus V1 upon 1 plus V2 minus 5 upon 1, and that is again V2. Fine. One more V2 is here also. One more V2, that is this. One more V1, sorry, that is this. That is V1 equal to 0. Now there are 3 V1 and also there are 3 V2. Now 3 V2 should become equals to V1 plus 5. Now Just you have to calculate it. That is just if we have to calculate it is V1 and V2. Just we have to calculate it V1 and V2. शिवानी गुप्ता, गुड इवनिंग सर। सर मेरी सिस्टर ने जो एमबीबीएस स्टेट सर्विस एग्जाम दिया है उसका 73 मार्क्स आ रहे हैं, अब उसको मेंस की प्रिपरेशन करनी है, मेंस के लिए कोचिंग ज्वाइन करना है, टेस्ट सीरीज। शिवानी, she should go for, if she clear first time prelims, she should go for coaching also, or some study materials and some interviews of topper, and test series should be must. Test series should be must. Now guys, what is the value of V1 and V2 here? By calculating the value of V1 and V2, what is the value of I? I should become equals to V1 minus V2 upon 1, that is V1 and V2. So the correct answer of this question is, first, subtract equation number 2 to equation number of 1, subtract equation number 2 to equation number of 1, then it should become equals to V2 minus V1 plus 20. Now we have to calculate V1 minus V2, that is V1 minus V2, and also we have to calculate V1 minus V2 plus 20. Now total for V1 minus V2 should equals to 20. So the value of V1 minus V2 should become equals to 5 ampere. And I should also equals to V1 minus V2 upon 1. That is the value of the current should be 5 ampere. This is the correct answer for this question. Can we move forward? Yes, sir. So this is the same for A exam, also in KPTCL. Yes, Aishwarya, this is also for A exam. Atul Kumar Tiwari, when will the AIATC completed ho jayega? Atul, my part will be completed before 24th of July. Fine. Okay. Now next. The SI unit of conductance is, what is the SI unit of conductance? Everybody should give the answer. What is the SI unit of conductance? The value of the SI unit of resistance is ohms, and conductance is the reciprocal of resistance. So that is ohm inverse, and ohm inverse is also called as Siemens. Ohm inverse is also called as Moho and Siemens. Fine. Fine. Next question. Determine the V0 and I0 in the circuit. What is the value of V0 and I0 in the circuit? I don't give you the option for this question. I never give you the option for this question. You have to just calculate the value of V0 and I0. You have to just calculate the value of V0 and I0. Calculate guys V0 and I0 fast. Calculate V0 and I0 fast. Calculate V0 and I0. So guys, what do you mean by V0 and I0? First, this is 12 volt. So that if a battery is of 12 volt, then its low potential should be 0 volt. Its high potential should be 12 volt. Now this I is here. So the first you have to make a equation that is of Kirchhoff's voltage law. That is called KVL equation. Fine, fine. Now this is a person here, and he have to come his place. Now this is 12 volt, so you have to mention this minus plus, that is 12. Now the current is flow from high potential to low potential, so 4 into I, that is plus minus, that is 4 into I, again plus minus, minus 2 V0, again minus plus, so it should be 4, again minus plus, that should be equals to V0 equals to 0. Now minus 2 V0 and V0 should become equals to minus V0, minus 4I should become equals to, that is minus 4 and minus 12, that is minus V0 and yes, minus 4I, and that should be equals to minus of 16. Now V0 plus 4I should become equals to 16. Just satisfy the option with this equation. V0 plus 4I equals to 16. V0 plus 4I equals to 16. V0 plus 4I equals to 16. Just satisfy the option. V0 equals to 4I plus 16. What is V0 here? What is V0 here? 48. What is 4I? Minus 8. So minus 8, 4I into minus 8 is what? 32. That should become equals to 16. The correct answer is 3. The 3 is the correct answer. That is the correct answer. Clear, eh? It should be clear or not? Yes, sir. It should be perfectly clear. Now we have to move for the next question. Just a minute, guys. Now move to the next question. Yes, I know it's buffering. Please refresh it. It should be corrected. Please refresh it. It should be corrected. It is just a glitch. Please refresh it. It should be corrected. It is just a glitch. Deepthi Gedam, just keep calm. Deepthi Gedam, just keep calm and start your study from now. Just keep calm first. Don't be worried about it. Taj, if there is a movie on Amazon Prime, then you can mail to the Amazon Prime that your sound is low, or you can just increase your volume, or you can use your speaker, or you can use your earphone. What should you do? There are 80 students right now, but only you are the person who have a problem of sound only. Nobody else here have a problem of sound. So man, you have to just increase your volume, nothing else. Otherwise, use the good qualities of earphones. What should I do, guys? It is a platform of YouTube. It is not my personal platform. Fine. Guys, find the Norton equivalent in the circuit. So first we have to find the Norton's resistance. What do you mean by the Norton resistance, guys? The Norton resistance should be this is current source, this is plus, this should be minus. The current source should be open circuited. Fine. The voltage source should be short circuited. Now 8, 4, 8, all three are in series. 8 and 4, 12, 12 and 8, 20, 20 and 5 is in parallel. 20 and 5 should be in parallel. That should be 20 into 5 upon 20 plus 5. That should be equals to 100 divided by 25. That should be equals to 4 ohm. The correct answer should be 4 ohms. So 4 ohm both are correct. Now we have to calculate the short circuit current here. That is called Norton current. What do you mean by Norton current, guys? Here we have to calculate the Norton current like this. Entire current should be flowing through this, now this, and overall current should become equal to this, and this should become equal to this. This should be completely omitted. And one more thing, 8 and 8 both should be connected in series. So 8 and 8 should become equals to 16. After that 16, and one more thing, after that 16, we have to apply the nodal here. This is V. What is the value of V? Incoming equal to 6. Then V minus 16 upon 4. V minus 16 upon 4 plus V minus 16 upon 4. Yes. And V minus 0 upon 16. V minus 0 upon 16. Now guys, we have to calculate the value of V, and V by 16 is your this. 4 and 16, 4 1 4, 4 4 just 16. That is 16. 16 is your LCM. 16, and then 4V minus 16 for the 64 plus V equal to 6 for the 24. 24 and 64 should be equals to what? 6, 7, 8, 88. That is 88. Now what is the value of V? V should become equals to 88. 88 by 16. That's it. The value of the correct answer is what? The value of the correct answer is 2 ampere with cross 4. 2 ampere with cross 4 ohm is the correct answer. You should just carry it. Fine. Now we have to move on the next question. Guys, put up energy in the session. Fast. An alternating voltage as a equation Vt equals to 200 sine 370 72. What is the value of RMS voltage and frequency? Guys, the value of RMS voltage is what? Maximum divided by root 2. What do we mean by RMS? That is maximum divided by root 2. What do we mean by maximum? The maximum should be equals to 200, and 200 divided by root 2. This is the RMS value. And what is the frequency here? Frequency is 377, guys. So omega should be equals to 377. Omega equals to 377. That means omega should become equals to F should become equals to 60 hertz. F should become equals to 60 hertz. Fine. Next question. Convert the delta network shown in the figure to an star equivalent network. Convert the delta network to an figure star equivalent network. Convert the delta network to the figure to star equivalent network. Now guys, this is 15, this is this. Now what do you mean by star here? This, and this. Guys, this is your RA, this is your R, this is your R. Guys, this is your RX, this is your RY, and this is your Z. Guys, what is the value of RX actually? The value of RX should become equals to, what is the value of RX? the value of Rx should become equals to 25 into 15. 25 into 15. Now 25 into 15 plus 25 into 10 and 10 into 15. That is 10 into 15 upon that is 10. 10, 10, 10 and 2.5. What do you mean by Rx? Rx should become equals to 5 5 to 25, 5 to 10, 25 into 5, 25, 15. 25 and 15 is what? 40. 40 plus 15 into 2.5. That is divided by 10. 5 to the 10, 5 3 is 15. 25 3 is 75. 75 37.5. 40 plus 37.5 is what? 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 There is no option in the given question, guys. So you have to just calculate it. If option is not given in the question, we don't have any option for this question. We don't have any option for this question. So you have to just apply whatever I apply for Rx. You should apply for whatever we should apply for Rx. You should apply for Ry and Rz also. Fine. Okay. This is a simple question. Oh no. Here is the option. Here is the option. Guys, what we have calculated? What we have calculated actually? What is the value of Rx? That is 25 75 75 by 2 37.5. What is the value of Rx here? 77.5 ohm. And here is the option here. Here is the option here. That is this. That is 37.5 ohms. Sorry, 77.5. This is the option. Only one option is there. Where is 77.5? Here 31. Here this. Here this. So we have to calculate like this. 77.5. We need not to calculate Ry and Rz. We need not to calculate Ry and Rz. We need not to calculate Ry and Rz. Fine. Okay. Next. In the given circuit below, what will be the value of RTH across the terminal A and B? What will be the value of RTH across terminal A and B? So you have to calculate RTH across terminal A and B. First, you have to calculate across A and B. You have to calculate across A and B. Guys, there is a voltage source should be short circuited. Here also voltage source short circuited. This voltage source short. This voltage source short. Both should be short or not? Yes. Plus 4 and 6 should be in parallel. Now A to the 16 by 10 plus 24 by 10 plus, now this should become also equals to parallel with this 12. Now the complete answer should be what? Just calculate, guys. What is the complete answer for this question? 24 and 16 is what? That is 40 divided by 4. So that is 4 parallel to 12. And 4 parallel to 12 is 4 into 12 into 4 by 16. That is 12 4 ja 48 divided by 16. That should be equals to 3 ohm. 16 3 ja 48. 16 4 ja 12 4 ja 12 to the 24. 48 divided by 16 to 61 is 16. 16 to 32. 16 3 is 48. I think 63 is the correct answer. Am I right or wrong? I think 3 is the correct answer. 8 and 2. 8 to the 16 divided by 10. 4 6 ja 24 divided by 10. Fine. That is 40 divided by 10 is 4. 4 and 12. 12 4 ja 48. 48 divided by 60. 3 ohm is the correct answer, guys. 3 ohm is the correct answer. 3 ohm is the correct answer. What is 4? 3 ohm is the correct, na? There is no option here. 3 ohm is the correct. 3 ohm is the correct. Don't forget your concept, guys. Don't forget your concept. The correct answer is 3 ohm. If it is not in the option, then leave it. But otherwise, the correct answer is 3 ohm. If it is not in the option, just leave it. Otherwise, the correct option is 3 ohm. Now we have to go for the next question. In the shown figure, what is the value of unknown resistance R? The voltmeter reads 4 volt. The total source voltage is 120 volt. The total source voltage is 120 volt. This is your R, this is your 4 volt, this is your 10 ohm. The total source voltage is this. What is the value of R? What is the value of R? Guys, here it is 10 kilo ohm. Guys, here it is 10 kilo ohm and 4 volt. What should be the value of current here, guys? What should be the value of current? The value of current should become equals to 4 divided by 10 kilo ohm. That should be equals to 0.4 milliampere. Now the value of current is 0.4 milliampere. Now this is 4 volt. What should be a voltage here? That is 120 volt. That is 120 volt. No 120. That is 116 volt. 116 volt. This is 116. This is 4. Overall is 120. So what is the value of R, guys? What is the value of this R? The value of this R is this current that is called I. So the value of R should become equals to 116 volt divided by current I. 116 divided by current I. What is the value of I? That is 0.4 milliampere. So guys, 0.4 milliampere is what? You have to calculate. 0.4 milliampere is 1160 divided by 4 kilo ohm. 4 1 is 4, 4 2 is 8, that is 290 is the correct answer. 290 is the correct answer. Fine? Yes, sure, sir. Can we go for the next question? Yes. In the circuit shown below, what will be the value of current through resistor R? What is the value of current through resistor R? Just calculate, jaldi, fast. Do fast. Do fast. What is the value of current? In the circuit shown below, what is the value of current through resistor R? What is the value of current through resistor R? So now guys, this is your resistance R. This is your resistance R. Here 10 into 2, 20 and 20 into 10. Here bridge is balanced. 10 into 20 and 20 into 10, bridge should be balanced. So the current should in the galvanometer should become equals to 0. The current in the galvanometer should be equals to 0. The current in the galvanometer should be equal to 0. Should be equals to 0. The current in the galvanometer should be equals to 0. Clear? Okay, fine. Can we go for the next question? Yes, sir. Go to the next question. In the circuit shown below, what will be the value of current through resistor R? What will be the value of current through resistor R? What will be the value of current through resistor R? What is the value of current through resistor R? Just find it, calculate it. Fast, calculate. Good. So whenever guys there is a tank circuit given to you, whenever there is a tank circuit given to you like this, a capacitor and RL, you just know what is the, what is the, this is not a current, this is not current. Actually just answer it should be, it is an impedance. It should ask to you the impedance. He is not asking you about the current, it should asking about the impedance, and this impedance is called as dynamic impedance. That is always L upon CR. That is L upon CR. That should be, he is not asking about current guys, he is asking about impedance, and that should become equals to L upon CR. That should become equals to L upon CR. You have to just learn it. It is here is a derivation for that by using the Laplace transformation, but you need not to learn about anything about Laplace transform. You just know the what is the impedance in the tank circuit, that is L upon CR, and that is also called as dynamic impedance of the tank circuit. Fine. Now we have to go for the next question. Dash is proportionality factor relating the charge between two metal surfaces. Dash is a proportionality factor relating the charge between the two metal surfaces. That means charge. Which factor is proportional to charge? Which factor is proportional to charge? Which factor is proportional to charge, guys? That is capacitance, inductance, both resistance and capacitance, or resistance. So the thing which is directly proportional to charge is always your what? That is Q equals to CV. That means what? that is capacitance. So capacitance is always proportional to, guys, charge in a parallel plate capacitor between two metal surfaces. Between two metal surfaces. Now we have to go for the next question. Select the correct figure for fall in voltage. Fall in voltage means V equals to minus IR. We have to identify what is V equals to minus IR. We have to identify here what is V equals to minus IR. Just identify what is minus VR. V equals to minus VR. You have to identify what is V equals to minus VR. You have to identify what is V equals to minus VR. Just identify. Fast. Just identify what is the value of V equals to minus VIR. Too fast, guys. Too fast. Too fast. Now, so guys, this is your plus sign, this is your minus sign. This now the thing is, guys, this is your current, this is also your current. Now, what do you mean by V equals to minus IR? The meaning of V equals to minus IR is that where there is a fall in voltage. Now the current is flow. There is R or not? No. Is there any R or not? No. Here is any R? Yes. Current is flow from high to low? Yes. That means V equals to IR. But here the current should flow from what? That is where the current is flow from what? High to low. That is current flow from what? In this direction. There is a current flow in this direction, and that is wrong. That is V equals to minus IR. So the correct answer is that is this. Fine. No, Rajan, it is correct. I sir, AI physics important question marathon link. Please send an exam date preparation. Yes, Himanshu, I know very well. From today, today 8 p.m. onwards till examination, I will completely explain all the question. I will completely explain all the questions of the physics portion. Don't worry at all. Mine part physics was completed before your examination. Don't worry. And I hope exam should also be postponed, because this is not an ethical way. This is not an ethical way to give the examination only after the form fill up for only 10 days. This is not a good way. So they have to postpone. But okay, if they don't postpone, then we also completed our syllabus before the time. Fine. Now guys, why this is not an option? Here V equals to minus IR. Here V is there, I is there, V is there, I is there. Where is R? Where is R? There is no resistance. How should we give V equals to IR? How should we give V equals to IR? How should we give V equals to IR? How should we equals to IR? How should we give V equals to IR? How should we give V equals to IR? Now Anjane Musturkar want to say something. Anjane, you have any doubt? Anjane, you have any doubt? Anjane, you have any doubt? You have any doubt? Yes, FF with kid from tomorrow. Yes, Shivani. Now we have to go for the next question. A 50 kilowatt DC shunt motor is loaded to draw rated armature current at any given speed. When driven at half of the rated speed by armature voltage control, then what would be the output power delivered by the motor? Then what would be the output power delivered by the motor? Then what would be the output power delivered by the motor? What would be the output power delivered by the motor? What would be the output power delivered by the motor? Fast, guys, fast. A 50 kilowatt DC shunt motor is loaded to draw rated armature current at a given speed. Now guys, the first thing you have to know the shortcut. If there is a DC shunt motor, drawing 50 kilowatt power at a given speed, when driven at half of the rated speed by armature voltage control, what would be the output power? Guys, the output power does not change. Output power does not change. Why? Because it is an armature voltage control method. In armature voltage control method, the output power, in armature voltage control method, the output power, so he is asking about output power. No. Okay, fine. When driven at half of the rated speed, so if speed becomes half, then power also becomes half. In armature voltage control method, torque is constant, so power equals to torque into speed. If torque is constant, power is directly proportional to speed. If speed becomes half, power becomes half. If speed becomes double, power becomes double. So if speed becomes 50 kilowatt to 25 kilowatt, the correct answer is 25 kilowatt. Correct? Okay, fine. If Wi is the iron loss and Wc is the full load copper loss in a transformer, then which of the following condition will be satisfied to obtain maximum efficiency at 4/5 load? Just calculate, guys. This is a beautiful question for your KPTCL A and J examination both. This is one of the beautiful questions. I want answer from all those students who are appearing for KPTCL and also from those students who are not appearing for KPTCL. Just give the answer for this question. It is a good question. Fast. Good. If Wi is the iron loss and Wc is the full load copper loss or transformer, which of the following condition will the satisfied to obtain maximum efficiency at 4/5 load? Now guys, here, what do you mean by x? X should become equals to under root of iron loss upon full load copper loss, that is rated copper loss. Here is x. What do you mean by x? Guys, here is x should become equals to 4 by 5. X should become equals to 4 by 5, and that is pi upon rated copper loss, and that should be in the root. So if we squaring both sides, that is 16 by 25 should become equals to iron loss upon copper loss. Now this should become equals to iron loss upon copper loss. What are the total losses, guys? Total losses are 25 plus 16, that is 31. Here is the percentage, that is iron and this is copper. Definitely copper loss is more compared to iron. But here is the question, like which of the following condition will have satisfied to obtain maximum efficiency? What do you mean by maximum efficiency? Guys, at maximum efficiency, iron loss will always equal to copper loss. This is the condition. Iron loss is always equals to copper loss. This is the condition at maximum efficiency. Every time I will tell you, don't be confused. Iron loss will always become to equal to copper loss at maximum efficiency. Fine? Okay, sir. Now, next question. The armature torque of a DC motor running at 1000 rpm is 100 Newton meter and the shaft torque of 90.45. Then iron and friction loss will be. Do fast, guys. Iron and friction loss will be too fast. Ranjit Kumar, you have to join the Testbook Pass. Already test series available for all J exams of this country, and that is called Testbook Pass. The armature torque of a DC motor running at 1000 rpm is 100 Newton meter and the shaft torque of 90.45 Newton meter. The iron and friction losses will be So guys, the thing is, so first thing I will tell you, this is your rotor. Rotor develop the torque which is called as mechanical torque. Now after mechanical torque, some torque will be lost in mechanical losses. Apart from that, the remaining torque should go to the shaft, and that is called shaft torque. That is called shaft torque. Now here you know the shaft torque, you know the mechanical power developed. So this minus this, that is this minus this, should become equals to mechanical losses torque. So the mechanical losses torque should be equals to, the torque lost in mechanical losses should become equals to 100 minus 100 minus 90.45. 100 minus 90.45. That should become equals to that should become equals to what? 9.55 Newton meter is the torque. Is the torque in the loss. Now the question examiner asked should be that losses. He is not asking about the torque, he is asking about the losses. Now the mechanical losses are called as iron and friction losses. So what do you mean by the relation between a torque and power? That is 2 pi nt by 60 should become equals to power. So this is 2, this is pi, this is speed. What do you mean by the speed here? The speed should is 1000 rpm. That is 1000 rpm. What is torque? That is 9.55 divided by 60 should become equals to power. Here this 1000 makes the kilowatt. That is 2 pi by 60 into 9.55. 2 pi by 60 into 9.55. Just calculated it, guys. Just calculated it. Ranjit, don't go for KPTCL. KPTCL is not the exam of outside this country. It is the exam of state of India. And in India, the curriculum is everywhere same. In India, in Karnataka also, the synchronous speed formula is 120F by P, and in UP also 120F by P. So all JEE exams of this country are of similar like, and all A exams of this country are of similar like. So you need not to just to see the picture. That is KPTCL JEE test series. Everybody in this country should fool to you that we have a test series. They don't have actually a test series. Fine. Okay, fine. So just practice the JEE questions, that is of other states also and other PSUs also. They are helpful. Don't go for KPTCL specifically. Now, guys, what is the shaft power? Just calculate. That is 9.55 into 2 into 3.14 divided by 60 into 1000, and that should become equals to 1000 watt. The 1000 watt is the correct answer. 1000 watt is the correct answer of this question. We have to go for the next question. If there is a break in 440 only 220 volt auto transformer in winding which is common to both LV and HV, then the output voltage on LV side will be. If there is a break in 440 only 220 volt auto transformer in winding which is common to both HV as well as LV side, then the output voltage on LV side is. Fast, guys, fast. Too fast. Do fast, guys. If there is a break in 440 oblique 220 volt auto transformer in winding which is common to both HV and LV, which is common to both HV as well as LV, then the output voltage on LV side will be. What do you mean by LV, output voltage on LV side? Guys, 440. This is the transformer. Fine. This is the two winding transformer. Fine. If there is a break in 440 oblique auto transform. Okay, fine. Guys, this is 440 volt and this is 220 volt. And there is a break. Fine. So this is your LV and this is your HP. What is the value across the LV? That is 220 is the low voltage side. But 220 is the low voltage side. But if he asks about what is the value at high voltage side, so high voltage side should be equals to 660 volt. Clear? So this is the primary winding, this is the secondary winding, there is a break. Out of the break, this is the LV side and this is the HV side. So 220 is the correct answer. Fine. Next. A DC generator without commutation is a DC generator without commutation is called as a DC generator without commutation is called as a DC generator with is 220 volt. Yes, Shivani, it is 220 volt is LV side. That is low voltage side of the transformer. A DC generator without commutation is N. If a DC generator and there is no commutator in it, commutator is called as mechanical rectifier. Clear? Nishant Aryas, आज SSC JEE. Nishant, daily 5 p.m. we are coming here not to solve previous year question of SSC JEE, because when we solve previous year question of SSC JEE, then we are not selected in SSC. We have to solve the questions similar like SSC, some different JEE exam previous year question, some new question, then we are able to select. So daily we are going to implement a different things. Fine. So daily if we are going for previous year of SSC JEE, then there is no selection, because everybody in this country just learn it all the previous year question of SSC JEE. So you have to just attend my daily 5 p.m. class, which is the best class across the country for all AE and JEE exam of this electrical. Fine. So you have to just attend my 5 p.m. class. Definitely you nailed it in your examination. But forget one thing from your mind, that we have to go for SSC JEE, SSC JEE, SSC JEE, SSC. SSC is nothing. SSC is nothing. A DC generator without combination, if there is no commutator guys in DC generator, then there is no DC generated EMF. Okay, so it is just like an AC generator. It is just like an AC generator. Even we also don't tell, even we also don't tell that it is induction. Why it is induction? Because in induction generator there is only a singly excited supply. But in DC there is a two excited supply. That was the reason we have to go for AC generator. Fine. Next. The power input to the rotor of 440 volt 50 Hz 6 pole 3 phase induction motor is 100 kilowatt. The rotor electromotive force is observed to make 100 complete alterations per minute. Calculate the slip. Just calculate the slip. Why, Subhash? Why? What is the reason behind that? What is the reason behind that? You want to take super coaching in test book? What is the reason behind that? What is the reason behind it? You want to take super coaching in test. What is the reason behind that? Yes, man. KPTCL is in this month only. The power input to a rotor of 440 volt 50 Hz 6 pole 3 phase induction motor is 100 kilowatt. The rotor electromotive force observed, that is rotor EMF observed to make 100 complete alteration per minute. What do you mean by 100 complete alteration, guys? 100 complete alteration means 100 cycles per minute. And 100 cycle per minute is 100 divided by 60 cycle per second, and this is your frequency, guys. So what do you mean? What is the frequency here? Here the frequency is 1.6 hertz. Here the frequency is 1.6 hertz. And guys, remember it, the frequency of rotor EMF. The rotor EMF frequency is always always S into F. The rotor EMF frequency is 1.6 Hz and this is your slip. And what do you mean by F? Here F is 50 Hz. There F is 50 Hz. This is your F. Guys, what do you mean by slip? That is 1.6 divided by 50, and 1.6 divided by 50 equals to 500. What do you mean by slip? Just calculate, guys, slip. Just calculate the slip, guys. Just calculate the slip. 16 divided by 500, that is 0.032, and that is 3.33%. The correct answer is 3.33%. Fine. Next question. In DC machine, the internal characteristics are plotted between. In DC machine, the internal characteristics are plotted between. Fast. Do fast. In DC machine, the internal characteristics are plotted between. Sir, yesterday I gave West Bengal exam. That is very easy. Sir, now question. Oh, confidence, sir. Good, good, good. Good, Atanu. Good, Atanu. Keep going. Keep going. Guys, just like the session. Guys, just like the session and cross 100. We want century for this question, this session. Guys, fast. Do fast. Cross the 100 barrier. Cross the 100 barrier. Do fast. In DC machine, the internal characteristics are plotted between. In DC machine, internal characteristics are plotted between EMF induced in the armature versus field current, terminal voltage versus load current, terminal voltage versus armature current, and EMF induced in the armature versus armature current. So guys, internal characteristics is what? Just give the answer. Internal characteristic is, that is EMF induced in armature versus armature current. Is it internal? Here terminal? No, there is no terminal for internal characteristic. Terminal voltage comes for the external characteristic. This is induced EMF versus armature current. Fine, fine, sir. Next question. In an alternator, the direction of alternating EMF produced in the stator conductor is given by. In an alternator, the direction of alternating EMF produced in the stator conductor. Guys, in alternator, the flux is rotating and the stator conductor are stationary. So I don't think there is a Kirchhoff law. I don't think there is a Fleming's left hand rule. You have to go for Fleming right hand Faraday. But in Fleming's right hand rule, you have to, there's two things. Fleming's right hand rule is applicable where there is a dynamic EMF, is produced. What do you mean by dynamic EMF, guys? What do you mean by dynamic EMF? Dynamic EMF means if flux is rotating and conductor is stationary, or if conductor is rotating and flux is stationary. That EMF is called as dynamic EMF. And in alternator also, there is a flux is rotating in nature and conductor is stationary. This is called Fleming's right hand rule. This is called Fleming's right hand rule. Now we have to go for the next question. The gross mechanical power developed by a DC motor is maximum when back EMF is. The gross mechanical power developed by a DC motor is maximum when back EMF is. The gross mechanical power developed by a DC motor is maximum when back EMF is. The gross mechanical power developed by a DC motor is maximum when the back EMF is this. So guys, it is a motor. First thing, it is a motor, and if motor is this, then back EMF equals to Vt by 2. That is terminal voltage half the applied voltage. That is equal to half the applied voltage. But if it is the case of generator, then terminal voltage is generated EMF by 2. Then terminal voltage is generated EMF by 2. Next question. The power factor of an induction motor operating at no load is around. The power factor of an induction motor operating at no load is around. The power factor of an induction motor operating at no load is around 0.9 lag, 0.2 lag, 0.29 lead, 0.2 lead. The power factor of an induction motor operating at no load is around. Too fast, guys. Yes, Akshay. This session is helpful for your all A and J examinations of this country. The power factor of an induction motor operating at no load is around. The power factor of an induction motor operating at no load is around 0.9 lag, 0.2 lag, 0. So guys, if there is an induction motor if there is an induction motor, then definitely it works on a lagging power factor. If there is a lagging power factor, then there is no option of leading. Second more thing, at no load, it draws a very high current and the power factor is very less, that is around 0.2 lakh. It's clear? Okay. Next, the power factor of a synchronous motor. The power factor of a synchronous motor improves with increase in excitation and may even become leading at high excitation. Decrease with decrease in excitation is independent of its excitation. Increase with loading for a given excitation. Increase with loading for a given excitation. So the power factor of a synchronous motor improve with increase in excitation and may even become leading at high excitation. Yes, it is correct. Decrease with decrease in excitation. So if excitation is decreased, definitely power factor will be decreased. Is independent of no. Increase with loading, no. The correct answer is 1 and 2 both are correct, but the exactly correct answer improve with increase in excitation and maybe even become leading at high excitation. 1 is the correct. Fine. Go for the next question. Which of the following statement about the core type transformer compared to shell type transformer? Yes, Asha Shetty. Yes. Sure. Which of the following statement about the core type transformer compared to shell type transformer is incorrect? So guys, the core in a core type transformer, windings surround the core. Fine. But in shell type transformer, core surround the winding. So there is an incorrect. Incorrect kya? In a core type transformer, core surround a considerable portion of the winding. No. Core doesn't surround, guys. Windings surround the core. That is, windings surround the core. So in a core type transformer, core does not surround the winding. There is always winding surround the core. Next, in which of the following tests, which may be used to measure the synchronous impedance, should the reading be taken in short time to avoid armature overheating? In which of the following tests, which may be used to measure the synchronous impedance, should be reading to be taken in short time to avoid armature overheating? So guys, the thing is, we have to take what? In which of the following tests which may be used to measure synchronous impedance? For synchronous impedance, should be reading to taken in short, avoid armature overheating. That is always short circuit characteristic test. In a generator, clear? In a generator, there are two types of characteristic. One is OC characteristic, another one is short circuit. For armature overheating, we have to go for the short circuit characteristic. We don't go for the open circuit characteristic, because whenever you are using an open circuit characteristics, sir, I think these questions are not related to J. Anjane, these questions are completely related to J. And one more thing, today I'm not going to calculate you, that is, if there is a voltage of 10 volt and current of 2 ampere, and you have to calculate current voltage divided by current 10 divided by 2 equal to 5 volt and happy. Yes, we have to solve it, because these questions are already that questions are already I am here come to give you some conceptual equation so that you can able to crack those questions in the examination which are like this, because the result part is definitely decided by these types of questions. The result can never be decided by that question where there is an energy meter where there is the beta is the meter constant, there is the voltage, current, time, and you have to calculate the number of revolution. that, and where is the creeping effect, creeping phenomena is occur, where is, why we should drill, why we should quality factor, which relay is used in a long transmission line. And these questions are you already knows. They all are very easy. Everybody should crack it. But some questions which are conceptually good, they are not able to crack by everybody. So you can get some edges in that question also. That's why today I am going to tell you these questions. Otherwise, if you able to understand something in Hindi, so from past 1 years, I'm continuously solving the questions at 5 p.m. my session. That is the biggest session of AEJ electrical in this country. So you can watch all my lectures at that time. All questions are of JE level, and this question is also of JE level. Fine. Now guys, we have to switch the subject and come to the different subject. Yes. Fine. A coil consists of 4,000 tons of copper wire having a cross-sectional area of 0.6 mm square. The mean length per, sorry, leave it. Yes. A 10 millihenry coil has a resistance of 100 ohms. At what frequency does XL equals to R? XL equals to R. Guys, do fast. In electrical beta, nobody can give you this much of questions on YouTube. You know very well. Everybody is going to solve the questions like impedance relay is used where? Medium transmission line. The length of medium transmission line is above 80 kilometer. Everybody knows there is no selection for by that questions. A 10 millihenry coil has a resistance of 100 ohm. At what frequency does XL equals to R? At what frequency does XL equals to R? At what frequency does XL equals to R? This is a simple question, guys. This is a simple question like, when XL equals to R, where XL is what, guys? Omega L, and omega L equals to R. What do you mean by omega here? That is R by L. What do you mean by R? That is 100 divided by 10 into 10 to the power minus 3. That is omega should become equals to 1000. Fine. Now that is 2 pi f equals to 1000. That means what? Frequency should become equals to 1000 divided by 2 pi. That is 500 by pi is the correct answer. I think 500 by pi is the correct answer, right? 10 to the power 4. 10 to the power 4. 10 to the power 4. That is 5000 divided by pi is the correct answer, I think. And 5000 divided by pi is always 3. That is 1591.5 watts. That is 1591.5 watts. Now we have to go for the next question. What will be the value of VA in the given circuit? Anjane, now your question is coming. You want this type of question? Now your question is coming. That is a very lallu question. Just solve. Find the value of VA. In a very simple way, this is a current source, 20 ampere current source is coming. Okay, what is this current? That is VA by 10. What is this current? That is VA by 25. So 20 should become equals to VA by 10 plus VA by 25. Now what is 10 and 25? 2 5 ja 10, 2 5 ja, sorry, 5 2 ja 5 5 ja, 5 1 ja, 5 and 25 2 ja 50. 50 is the correct answer. 50 10 5 5 VA plus 2 VA 7 VA. So 7 VA, what is the value of VA? I think 142.5 is the correct answer. 142.5 is the correct answer. Fine. Yes sir, can we go for the next question? Yes sir, go for the next. Two coil is differentially connection. Yeah, remember differentially connection. Have a self inductance of 2 millihenry and 4 millihenry, and the mutual inductance is 0.5 millihenry. The equivalent inductance of the series opposing combination will be. Equivalent inductance of a series opposing combination will be. Equivalent inductance of a series opposing combination will be. Do fast, guys. Do fast. Two coils is in differentially connection have a self inductance of 2 millihenry and 4 millihenry and mutual inductance of 0.15 millihenry. The equivalent inductance of series opposing combination will be. What do you mean by equivalent inductance of series opposing? Two coils of differentially connected, fine, and have a self inductance of this and mutual inductance. The equivalent inductance of series opposing. Now guys, what do you mean by equivalent inductance of series opposing? That is this and that is this. Now this is 2 millihenry and that is 4 millihenry. So guys, L equivalent should become equals to L1 plus L2 minus of 2M. So L1 plus L2 minus of 2M, 4 or 2, 6 millihenry minus 2 times of 0.15, that is 0.3, and that should become equals to 5.7 millihenry. The correct answer is 5.7 millihenry. Yes, yes, Ranjit, at 8 p.m. At 8 p.m. Fine. Next, for the network shown in the figure, calculate the power developed by the resistor R1 and R2 respectively. For the network shown in the figure, calculate the value of R1 and R2 respectively. No. R1 and R2, no. This is 9 ampere. This is I1. This is I2. You have to calculate the power in R1 and R2. You have to calculate power in R1 and R2. First, guys, this is I1 and this is I2, this is 8 and this is 4, this is 9. So this resistance is high, double than this. So the current is 3 ampere and the current is 6 ampere. Fine. Now, what is the value of power here? That is 3 square into 8. And what is the power here? That is 6 square into 4. So 8 9 is 72 and 36 into 4, that is 333 and 3. That is 120 and 134 is the correct answer. 144 is the correct answer. Fine. Can we go for the next question? Sure, sir. Next. An AC source is delivering power to a complex and ZL4 plus 3J. The maximum power is transferred if the source impedance is. Too fast, guys. Shivani asking that how can I find the current? Okay, Shivani, fine. Shivani, here the total current in both the resistor is 9 ampere and here is 8 ohm and here is 4 ohm. So in this branch, the resistance is double than this branch. So in this branch, current is half. So what should be the values of both the current such that the current in this branch should be half? So if there is a 6 ampere, there should be a 3 ampere. So that 3 plus 6 should become equals to 9. Just an intelligence, nothing else. Some students are thinking, what happened to you, sir, today? Am I right or wrong? What happened to you, sir, today? You are completely in English. Are you like it or not? Are you able to understand like or not? Guys, jaldi. An AC source is delivering power to a complex and ZL equals to 4 plus 3J. 4 plus 3J, the maximum power is transferred if the source impedance is the. I know, Dipendu, you are continuously writing this message. Today I can feel so blessed to like teacher as you. Oh, okay. An AC source is delivering power to a complex and ZL equals to 4 plus 3J. The maximum power is transferred. The maximum power is transferred if the source impedance is. So guys, if the source impedance is what? Maximum power transferred if the source impedance is low. If an AC source delivering power to a complex and ZL equals to the source impedance is what? Source impedance should always, guys, equals to 4 minus 3J. That is 4 minus 3J. Okay, Sachin. Enjoy. Next question. In the divider circuit, if RL is attached in parallel to R2, the voltage across R1 doubles, what will be the value of RL? Now guys, it's one of the wonderful question I have today. Guys, okay, fine. Guys, if RL is there in parallel to R2, fine. It is a voltage divider circuit, right? If in the divider circuit, if RL is attached in parallel to R2, the voltage across R1 doubles, the value across R1 doubles. That means what? First thing, here is the voltage across R1, here is the voltage across R2. Fine. This is your supply voltage. Now the value of RL is connected in parallel with this, so that the voltage across this becomes double. So what is the value of RL here? So first you have to calculate the value of voltage here. Fine. So that is Vs into 1K upon 3K plus 1K. That is Vs by 4. This is the voltage across this. Now this voltage becomes doubled when this RL is connected. This voltage becomes double. That means here now the voltage becomes Vs by 2 and here the voltage becomes Vs by 2. That means what? This total combination have a voltage Vs by 2 and this is also have a voltage Vs by 2. So that means both have the same resistance. Here is 3 kilo ohm. What should be this? So that they can become 1 kilo ohm. So 3 into RL upon 3 plus RL should become equals to this. That is 3 plus 3 RL equal to 3 plus RL. That means what? RL should become equals to 3 by 2 ohms. The correct answer is 3 by 2 ohms. A very simple question of today's class. Oh, Imran, love you, man. Where are you right now? Where are you, Imran, right now? Are you fine or not? I know you. Can we go for the next question? Yes, sir. You can go for the next question. Now, the RMS value of a sinusoidal supply whose peak value is 50. The RMS value of a sinusoidal supply whose peak value is 50. The RMS value of a sinusoidal supply whose peak value is 50. So, guys, what do you mean by RMS? RMS equals to maximum divided by root 2. Is it correct or wrong? Yes, it is correct. Clear? That is 50 by root 2 is the correct answer. Okay. Now we have to go for the next question. A voltage, leave it. This is not a good question. Yes, this is the good one. In a series RLC circuit, R equals to 1 kilo ohm, L equals to 10 microhenry, C equals to 1 microfarad, and source voltage is 10 volt. The current in the circuit at resonance is. Calculate, guys. The current in the circuit at resonance is. In a series RLC circuit, if R equals to 1 kilo ohm and L equals to 10 microhenry, C equals to 1 microfarad, and source voltage is 10 volt, the current in the series circuit at resonance, the current is always equals to V by R. What is the value of V? V is voltage 10 volt, R is 1 kilo ohm. That is, current should become equals to 10 milliampere. Can we go for the next? Yes. A 15 millihenry is connected in series with another coil. The total inductance in series addition and series opposition is 70 millihenry and 30. Find the self-inductance of the coil. I am not feeling well. I got cough and cold. So I enjoy my cough and cold with me. It is very good. I am not irritated by it. I really like it. A 15 millihenry is connected in series with another coil. The total inductance in series addition and the series opposition is this. Find the self-inductance of the coil. A 15 millihenry is connected in series with another coil. Find the total inductance. Series adding is this, series opposing is this. Okay. Now guys, series adding is what? L1 plus L2 plus 2M. That should be equals to 70. And L1 plus L2 series opposing is what? That should become equals to 30. Now we have to add both the equation, so that 2 times of L1 plus L2 should become equals to 100. So L1 plus L2 should become equals to 50. Now this is L1 plus L2. Now it is a 15 millihenry, a coil, another coil is what? 35 millihenry. The correct answer is 35 millihenry. The correct answer is 35 millihenry. Next question, guys. If the current in one of the coil changes from 20 ampere to 10 ampere in 0.2 seconds, the EMF induced in the other coil is 100 volt, then the mutual inductance of a pair of coil is, Oh, Imran, love you, man. Congrats. At which post PGCIL? At which post PGCIL? As an apprenticeship, JE, field supervisor, field assistant, which post you are working on PGCIL? Congrats, Imran. Happy Eid. Eid Mubarak ho. If the current in one of the coil change from 20 ampere to 10 ampere in 0.2 seconds, the EMF induced in another coil is 100 volt, then the mutual inductance of the pair of coil is, So guys, this is what E equals to N d phi by dt or M di by dt. What do we mean by EMF here? EMF should equals to 100 volt. This is your mutual inductance. What do we mean by current? Current is from 20 ampere to 10 ampere. That is change of current is 10 ampere, and in 0.2 second that is 0.2. Now guys, this should become equals to 100. So 100 cancels. That should become equals to 2 Henry. So 2 Henry is the correct answer. Fine. Next question. The full scale deflection torque of 20 ampere moving iron emitter is 6 into 10 to the power minus 5. What is the rate of change of self-inductance with respect to deflection of the pointer of the emitter at full scale? Too fast, guys. Too fast. The full scale deflecting torque of a 20 ampere moving iron emitter is 6 into 10 to the power minus 5 Newton meter. What is the rate of change of self-inductance? As a diploma trainee, love you, Imran, man. Love you. Love you, Imran. Imran, just text me on Telegram. Just text me on Telegram. Imran, just text me on Telegram, man. Just text me on Telegram after the class. Just text me. Okay? Just text me. The full scale deflecting torque of a 20 ampere moving iron emitter is 6 into 10 to the power minus 5 Newton meter. What is the rate of change of self-inductance with respect to the deflection of the pointer of the emitter at full scale? Guys, this is deflecting torque, that is half I square dl by d theta. Fine. Okay. And guys, what do you mean by deflecting torque? That is 6 into 10 to the power minus 5 should become equals to half into I square. What do you mean by I square? That is 20 square into dl by d theta. Clear? Okay, fine, sir. Now the value of dl by d theta is dl by d theta should become equals to dl by d theta should become equals to, that is 12 divided by 400. Yes, and divide into 10 to the power of minus 5. So that is 3 Yes, yes, 0.3 microhenry per radian. 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 Fine, fine, sir. Next. Which of the following statements is not an advantage of electrodynamic instrument? Which of the following statement is not an advantage of electrodynamic instrument? Which of the following statement is not an advantage of electrodynamic instrument? Free from hysteresis, not an advantage. What do you mean by, guys, not an advantage? That is disadvantage. And disadvantage is low sensitivity. Disadvantage is low sensitivity. So today, guys, I am I explain all of these questions, which are from some of are from network, some are from machine, some are from measurements, and I hope you like very well. I hope you like very well. Apart from that, guys, I want to tell you something regarding one more thing. That is, I am just showing you. I am showing you. Yes. So, guys, as you know, there is a video. My video is just behind to me. You just see the video and go to the description box. Go to the description before and now go to the description box. Here in description box, guys, there is a link that is called A and J with super coaching with India super coaching with super educators. Guys, the thing is, Testbook is launching a very good product for you that is called Testbook Super Coaching. So if all you are from electrical branch, I just open the link that is A and J electrical. Whenever, guys, I open the link A and J electrical, then you just see this page, and after seeing this page and you want to prepare for your all J exams of this country, if you want to prepare for all your J exam of this country, you have the Testbook Super Coaching. What is the reason behind that, guys? In Testbook Super Coaching, as you think just I want to study by Mohit sir, fine. So in Super Coaching, guys, my batch is there that is called Mohit Kasani Electrical Engineering and Electrical J Complete Course. This batch is of around more than around almost 400 hours. After that, guys, after learning from this batch, you can never go for any of the subject. You never go for any of the subject. In Super Coaching also, you get 5,000 plus practice questions. In 5,000 plus practice question, mock test completely, clear it, mock test completely. Apart from that, complete question bank, that is 5,000 practice question, completely question bank. And also, guys, one more important thing is that you get my live classes for revision, for previous year question, and for also your one-to-one mentoring and doubt session. My all live classes are on Monday and Thursday, that is tomorrow, and daily of 2 hours. Apart from that, YouTube classes which are you are already studying. Fine. Apart from that, guys, in Super Coaching also, you can also learn from other courses which are conducted by other organizations of this country, and they are expert in electrical also, clear it, electrical also. So you can also learn from them. You can also watching their recorded videos. Fine. So, guys, for enrolling the A Super Coaching, you have to just scroll down to the bottom. If you want to enroll for 12 months, I can hide myself. If you want, no, I need not to hide myself. So, guys, if you want to enroll in the Super Coaching, let's suppose if you want to enroll for 12 months, that is 563 rupees per month. But it is costly, I know. It is costly. So you have to just apply a coupon code here. Get exciting offer inside, apply coupon. Whenever you apply the coupon is Mohit K. The coupon is Mohit K, M-O-H-I-T, that is my name, and K, that is my surname, that is Mohit K. Then this complete batch will be given to you at only 450 rupees per month, and that is even not a per day single cup of tea. That is 450 rupees per month. Okay, this is a Testbook Super Coaching product. You have to enroll in it. Apart from that, guys, I will give you my Telegram link to you also, so that if any problem, you can just told to me, so that I can able to solve to you. I will give my Telegram ID to you also in my description box. In chat box, guys, I will give to Telegram channel ID also. Anushka, preparation going for an exam in Bangalore, sir. Please make a video on full AE KPTCL exam on 24th July. Please do before that. It would be a great help. Please do it by next video. Okay, Anusha? Sure. Sir, your voice is not clear. Muhammad Kaf. सर AAI-ADC एग्जाम के लिए स्ट्रेटेजी होना चाहिए, इतना जल्दी एग्जाम होने की एक्सपेक्टेशन नहीं थी सर। यस पीपल आई नो, है ना, इट शुड, बट व्हाट शुड वी डू, है ना, वी डोंट हैव एनीथिंग इन आवर हैंड, है ना, वी डोंट हैव एक्चुअली एनीथिंग इन आवर हैंड, सो व्हाट शुड वी डू यार, व्हाट शुड वी डू, बट वी विल फाइट, दैट्स इट। सो गाइस आई विल गिव यू माय टेलीग्राम चैनल, yes Visha Lakshmi at 5 p.m. and this is my telegram channel guys, I will give to you so that you can today I will leave early, Anna, because I don't think I am not feeling well, I have a cough cold and a severe cough cold, so I am not able to continuously talk to you, but I will try my best. So guys, this is my telegram channel, you have to just join it. Fine. Okay, so guys, we will meet in the next session, so thank you very much again, bye bye, take care and love you everybody. We can meet to the next